This is the introductory lecture to section 1.4. We have two ideas to talk about. The first idea is finding the equation of a line. We have two lines graphed here, and we will look at the equation of the line graphed in red first between the points 2, 1, and 4, 3. So to write the equation of a line, we need two pieces of information. The first piece of information we need is a slope, which is often denoted with the letter m, which is a change in the y direction divided by a change in the x direction. And we can illustrate that in this picture right here, change in y divided by change in x. Okay, so change in y, to find that slope, it's the difference in the y coordinates. So in this case, that's 3 minus 1 divided by 4 minus 2, which is 2 divided by 2, or 1. So to write the equation of the line, once we have the slope, all we need is a point. We can use any point on that line. So we'll choose one of the two we just used to find the slope. Let's choose the point 4, 3 with slope equal to 1. We can use the point slope form of the line, which is y minus the y coordinate of the point is equal to the slope times x minus the x coordinate of the point. We could write this line in slope-intercept form also, but we learn just as much information from point-slope form, and we're less likely to make algebra errors. Okay, let's do the same thing for the other line, which is through the points -1, 1 and -2, 3. So the slope of that line is again the change in y, which in this case is 3 minus 1 divided by -2 minus -1, which is 2 divided by -1, or -2. Okay, so to write the equation, we need a point. Again, we can pick either one. Let's pick -2, 3, and we're going to use that point with our slope, which is -2, and then slope, point slope form, the equation of that line is y minus 3 is equal to -2 times x minus a -2 is +2. Okay, so that's the equation of a line. We're going to do this in lots of different ways this quarter. Here's the equation of a couple lines through 2 points. The key being we need a point and a slope to find the equation of any line. Okay, the second idea is the idea of a secant line to a curve. So here's a graph of the function x minus 1 quantity squared. And on this graph, I've drawn a secant line through the point 1, 0, and the point 3/2, comma, well, whatever the output of the function is at 3/2. So I'll call that f of 3/2 for now. So we have 2 points almost, and we can use those to find the equation of the secant line. Before we do that, though, we need to know what the output of the function is at 3/2. Well, that's just 3/2 minus 1 squared, which is 1/2 squared, or 1/4. So now our 2 points are 1, 0 and 3/2, comma, 1/4. All right, so the slope of our line then, again, is the change in y, which is, sorry about that, 1/4 minus 0 divided by the change in x, which is 3/2 minus 1. This is 1/4 divided by 1/2. Multiply both numerator and denominator there by 2, gets us to 2/4, or 1/2. Okay, so now we have the slope of our line. It is 1/2. We have 2 points it goes through. We'll choose this one, and write down then the equation of our tangent line, which is y minus the y coordinate of our point, which is 0, is equal to the slope times x minus the x coordinate. This is the secant line. I may have just said tangent. I apologize. All right, there's a secant line and how we would go about finding the equation of that secant line. The activity in section 1.4 is going to ask you to investigate multiple secant lines to this same function. And so go ahead and give that a shot.